Hello, this is Mr. Waterman. This is lesson 7.3, geometry using similar right triangles. This is part 2. So in part 1 we were showing that if you draw an altitude within a right triangle to the hypotenuse, that it does form 3 similar triangles. And so we're going on to another example, extra example 3. So this one we already have drawn the altitude in the triangle, and we've been given side lengths. We've been given the hypotenuse of the big triangle is 10. Then this smaller triangle off here at the end, we have one leg length of 2 and a hypotenuse of k. So what we're going to do is draw the 3 similar triangles and what we know about them. So first of all, we take the outer triangle, this big one, and we go ahead and redraw it down here. And so we've got a hypotenuse of 10 and the short leg is k. If I take the medium-sized triangle, and that's this one right here, and I redraw it, I end up with this. And so this leg that's up on top here is going to be 10 minus 2 or 8. So we've drawn that here. And that's all we know. We don't know this side length, and we don't know the hypotenuse length. So we don't know enough. So that isn't going to be useful. So we're going to go ahead and just cross that off. And then finally, we're going to redraw the smallest triangle and see if this will help us. So we're going to put the long leg along the bottom, just like this original big triangle. And we're going to put the short leg up the right side and then the hypotenuse across the top. And on this one, we know that the hypotenuse here is k. And we also know that the short leg is 2. So now we have enough information to write a proportion. We have 2 side lengths here and the corresponding side lengths here, and we know that the sides are in proportion because these are similar triangles. So what we'll do now is see if we can get this thing out of the way, and we can't. There we go. And so now I go ahead and I write the proportion, and so I put corresponding sides over each other. So I put the hypotenuse of the big triangle on the left over the hypotenuse of the triangle on the right. And then I put the side length k of the short side of this triangle right here over the short side of this triangle on the right. I put the 2 there. And now I go about solving this. We learned a few chapters ago that you could solve these proportions. One way is by cross multiplying, so we do that. So I multiply the 2 times the 10, and I get 20. I multiply k times k, and I get k squared. So to go ahead and find the value of k, I square root both sides of this equation, and I get k equals the square root of 20, which simplifies down to 2 square roots of 5, or approximately equals 4.47. All right? And let's see if that's reasonable. If k is about 4.5, let's just write that here on these 2 sides and see if that makes any sense at all. So first of all, we've got a big triangle. It's got a hypotenuse of 10, and it's got a short leg of 4.5. That seems reasonable. Hypotenuse is the longest side. And then over here I have the short leg is 2, and the hypotenuse is going to be 4.5. So that seems about right. It's a little more than twice as big. That was true of this triangle. So I'm thinking that we've solved this correctly. So we'll go ahead and put a box around our answer. And that's it for the lesson.